Hello everyone. So in this session we are going to cover the third part of our Dapp development. So in this part we are going to talk about the user interface for our Dapp. So we'll get the overview of the user interface, and then we are going to have a brief discussion about Web3 framework, what Web3 is and how it is utilized. Then we are going to develop some logic for interacting with our deployed contract. So in our last session we got our contract deployed, which contains logic for adopting the pets. So we will develop a logic in our user interface to interact with that deployed contract on the contract which is deployed on the blockchain. And finally, we'll discuss about a very key difference between the types of interaction we can have on the blockchain. So these interactions are either these interactions fall under two categories. They can be either transaction or calls. Okay, so this is very important concept to understand, because the way you make the transaction, the interaction then defines whether you will get charged or not during the execution of the interaction on the blockchain. Okay, so let's get started. I have my virtual machine running and I got connected over here. So the first thing I'm gonna do is we'll open up our terminal and start the Visual Studio. So I'm going to desktop, Ethereum, demos, and we'll get into our Petshop demo. Alright, here I'm going to open it in the Visual Studio. Code is opening. Alright. Right, so the truffle box gives us the user interface out of the box. We don't need to develop it. And if you go to the SRC, here you have all the logic for our user interface. Everything is built using the Node.js libraries and various other JavaScript libraries. So we have out of the box user interface built with us in this box. So that's another advantage we get by using the box. Okay, next thing we need to do is, in the JS folder we have this app.js file, and if you see in this app.js file there is some code already written, but there are other places where we need to put our code. Okay, so during this session we are going to put the code, and then we are talk about what is the logic within the code and how it is interacting with, how it is going to interact with our deployed contract through Web3 library. Okay, now instead of then again having the code developed from scratch, we have it already in our demo solution folder. So I'll go to the Ethereum demo solution and I will open the folder. So here we have the SRC folder. In this SRC folder, JS and app.js, I'm just going to copy the entire code from here into our project, and then let's discuss the logic which we have inside app.js. Okay, so the first thing we are going to do is we'll go to the init web function. So in the init web function, what we are trying to do is, in our next session anyway, we are going to talk about the Web3 provider, okay, but let's discuss it here. So in the init web function, we need to interact with the blockchain contract, right? So in JavaScript, there is this framework called Web3. This Web3 framework, it does all the heavy lifting of giving you a sort of a wrapper through which you can interact with Ethereum blockchain, okay? So this Web3 framework is what we are going to utilize. Web3 framework is basically the middleman between your application and the blockchain, okay? So in order for us to interact with the blockchain, we need to define a Web3 provider, okay? And this Web3 provider is a singleton, what you say, it follows the singleton pattern, wherein we'll have a single instance throughout our application to interact with the blockchain. So what we are doing is, when our application initialized, okay, so in our app.js we have this function. So at the time of initialization of our user interface, this function will get called, and this function is first checking if we already have a Web3 instance with us, okay, Web3 provider, okay. Now, as I said, this is a singleton, it follows the singleton pattern. So in case we already have the Web3 reference, then in that case we are going to get that Web3 provider and assign it to this variable app.web3 provider, okay. So in our application, we are going to interact to the blockchain through this Web3 provider variable, okay, which is an application level variable, okay. So what we are checking is, if Web3 is already initialized, then use the current provider within Web3, okay. And when we are going to test the application, this thing will become more clear. And if we don't have the Web3 provider, in that case we are asking Web3 to give us a new provider, okay. And another thing you will notice here is, we are going to utilize the Ganache test blockchain for our testing. So that's why here, when we are asking for a new provider, we are asking it to get the provider from our Ganache blockchain, okay. So this is what we are doing in this function. I hope it is clear. Okay, next thing is, we will go and get into this function called Init Contract, okay. So again, we are calling this Init Contract function, okay, after we get the Web3 reference, okay. So what this function is doing, the Init Contract function is calling this getJSON function, and this function will then give us the data, okay. So the logic over here in this function is to basically get the contract information around our adoption contract and then assign it to a variable, okay. So the way we have in a typical programming language, we have something called as API, application programming interface. So similarly, for Ethereum, to interact with the contract, we have something called as application binary interface, ABI. So the application binary interface wraps the whole functionality of the deployed contract, and then it gives you an interface through which you can call various methods of the contract, access the getter and setter methods of the variables within the contract, and so on, okay. So what we are doing is, through getJSON, we are getting the ABI, application binary interface, and from this ABI we are then creating an instance of our adoption contract. So the way it will work is, we'll call this function, or the application at the time of initialization will call this function. It will get the data of the contract through Web3 from the blockchain, and then we are assigning that data to adoption artifact. This adoption artifact variable is basically the ABI, application binary interface. And then from this ABI, we are creating an instance of our truffle contract. Okay, and the type of that truffle contract is of adoption. Okay, right. So we have our adoption contract created through this statement. Okay, and next thing we are doing is we are setting the web3 provider to this value. Okay, so in our previous function, in the init web function, we had assigned the web3 provider to our application variable called web3 provider, and now in our contract instance we are setting the provider for this contract to that application level variable. So this way, when we are going to interact with our adoption contract, that interaction to the blockchain will happen through this web3 provider, which is nothing but our web3 provider we got during the initialization. And again, at this point, if all these things look confusing to you, it will become more clear when we are going to test the application. At that time, we are again going back and revise the entire code as we do the testing of the application. Okay, so after getting creating the instance of contract and setting the provider, we are calling another method, okay, called mark adopted. Okay, so what this method is doing, so this is the third method in our application. So if you go down here, you will see the mark adopted. This method is basically getting the instance of our contract. Okay, from that instance, if you see, so we have this adopter instance here. We create one variable. Okay, and to that variable, what we are doing is, if our contract, okay, the adoption contract which we initialized in our previous method, so if that contract is deployed, so this is an asynchronous call to the blockchain. So this will see or check that the adoption contract is deployed. So once it is deployed, then this promise is getting executed, and in this promise we are going to receive the instance of the contract. Okay, so through this ABI we are checking if the contract is deployed, and if it is, then we are getting this callback, and in this callback we will receive the instance of the contract, and we are assigning that instance to our adoption instance variable. Okay, and then we are returning that variable dot get adopter dot call method. Okay, now here is the important thing. Okay, in our actual contract we had this method called get adopters, right? So let me just open our contracts. So this is the contract we created in our previous session, and here you will see there is this get adopters method, right? So it was returning the array of the adopters. Then we deployed this contract in our blockchain. So in our blockchain, the contract is there at a particular memory address. Now we can invoke the methods and getter and setter on the variables. Okay, now when we invoke those methods can be of two types. Okay, there can be one method which will just read the data from the blockchain. So these are the reader methods. And then there can be methods which will alter the state of the contract on the blockchain. Okay, like for example updating some variable value on the blockchain, right? So what Ethereum allows us is, it allows us to call those methods which do not change the state of the blockchain. Okay, so such methods, if you want to call, you will use the call method. And if you are going to invoke a method and that method is resulting in some changes on the blockchain, then such call will be called as transaction. Okay, so the read-only methods are calls. The methods which change or alter the state of the blockchain are transactions. Now, why we make this distinction? The reason to make this distinction is because if there is any state change happening on the blockchain, then Ethereum will charge you for those transactions. And that charge happen in terms of the gas price. Okay, so if you remember, when we last time deployed our contract, initially in our wallet we had 100 Ethereum, and after deployment there was some deduction in that value, so it reduced from 100 to some 99 point some value, right? So why that happened is because that deployment itself executed some transaction, changed the state of the blockchain, and as a result we were charged for that transaction. So this is very key difference between a transaction and a call, because if there is a method which just read the data from blockchain, you can simply call that method, and by default that method invocation will be a transaction. So even though if you are not changing any state of the blockchain, you will get charged. Why? Because you invoked the function as a transaction. So this is the default behavior. So if you want to save yourself from accruing any gas cost, then when you are calling a read-only function, then in that case after the function name you need to use the call method. Okay, so that's why you will see that this is our contract instance, and then we have the method, right? So we could have simply said get adapters. In that case, so for example, if I remove this call, okay, this is a perfectly valid statement which will get executed. But the problem is, this from an Ethereum blockchain perspective will be a transaction and you will get charged for this invocation. But if I call this get adapter and I know that this is just a read-only function, in that case Ethereum will consider it as a call and not as a transaction, and as a result I will not get charged for this get adapter invocation. So this is a very key and very important concept when it comes to Ethereum the contract invocation, and you need to understand that. Okay, so here we created the instance of the contract, got our get adapters method, and if you remember the logic in our get adapters method, what we are doing is we are returning the entire array of adapters, the variable adapter which is of type address. Okay, so the next thing we are doing is, once this call, so this call itself is asynchronous. Okay, so that's why we have a promise over here. Okay, so there are two promises happening. One is, first we are deploying the contract, and then after that promise we are creating an instance, and on that instance we are calling the get adapters method, and that promise will then execute this. Then, and here what we are doing is the adapters, okay, we are getting as a result of get adapters, because it returns the array. We are going through that array. Okay, we are looping through that array, and in that we are checking that if the address is blank or 0. Okay, now this is again a very important statement. So what happens is, when variables are created on the blockchain, Ethereum assigns them this 0 value. Okay, so if you remember in our adoption contract, adapters is an array of type address. So Ethereum, in other programming language you might have observed that variables are initialized to null values or none values or empty values and like that, but in case of Ethereum, if it is of type address, they are given 0 addresses. So instead of checking for a null value or empty value, we are checking for 0 address. Okay, so what we are doing is, in our contract instance, if there is any adoption happen for a particular pet, So for that pet, we are going to disable one button, okay, so that there won't be any further adoption of that pet, and on that button we are going to display success. Okay, so when we are going to do the testing, you will see it in action. You will see a user interface with all different pets, and that below that pet's image you will see one button for adoption. So if it is already adopted, you will see the text success. If it is not, then you will be able to adopt that pet. Okay, so if it is already adopted, that button will be disabled, okay, and the text will change to success. Okay, so this statement will do that or execute that logic. Again, when we are going to do the testing, this will become even more clear. Okay, right. And now the final thing in our code is to look at one event, one function which will be called on a particular event. The event is when we are clicking on adopt button on the user interface. In that case, this event will be called, and here all we are going to do is we are going to mark that particular pet as adopted. Okay, right. So let's go through the logic here. So the first thing we do here is, after we receive the event, we get the pet ID, okay, from the user interface, and then we create the adoption instance, and then we have this web3 invocation where we get the accounts, and we assign those accounts to we assign the first variable from the accounts to this variable. So here from the user interface we will receive this event, and then in the event we will have the various accounts. Okay, those accounts are the accounts which we get from our test blockchain, right? So Ganesh, when we start, it gives us a list of accounts, right? It gives you around 10 accounts, I guess, for testing purpose. Okay, so this web3 interface has this method through which we can access those accounts. Okay, so for us to invoke a particular method on our adoption contract, we just need one single account, right? So that's why what we will do is, once we call the get accounts through the web3, we will choose the very first account for our testing purpose, okay, for our adoption purpose, and then here we are going to call the contract. Okay, so just like in our previous method, here also we will check if the adoption contract is deployed, and if it is, then we are going to get the instance of the deployed contract, okay, through the application ABI, we call it, right, the application binary interface, and then we are going to call the adopt method. Okay, so this adopt method is there in our contract. So this method. Okay, now here you remember the difference between calling adopt and calling the get adopters. So in our previous method we called get adopters. In that we appended we had that get adopters dot call method, because that was a call, we don't want to incur any cost, so we had dot call. But here we are calling the adopt method, and this adopt method, it changes the state of the variable, right? So here the variable adopters is assigned the address of the one who is invoking the contract, right? And if you remember in our last session, I said that when you call any method, message.sender will give you the address of the account who is invoking the method, right? So here we had some accounts with us. We got the first account, and through that first account we are calling our our adopt method, right? So here we are passing the pet ID, and you will see from we are passing the account, right? So the message dot sender will have that address, and it will get assigned to the particular pet ID's adopter. The array add that pet ID into this variable. Okay, so we are calling that method, and once that method is called, then we are marking that pet as adopted. So mark adopted method will be called, which we discussed just before this, and this mark adopted method will then disable the button below that pet. Okay, so this is the logic we have in our app.js application. So the logic over here is, first we are doing initialization, okay, to get our instance of web3 handler. After that we are checking. So let's go one by one through the methods we just discussed. Okay, so the first thing we discuss is initializing our we checked the if we have the web3 provider. If not, then we initialize it through our blockchain, the local blockchain. Over here in the init web function. The next thing we did is we looked at the get JSON, and here we got the contract ABI, sorry. Okay, we got the ABI, and we set that ABI to our application level variable. And the third thing we did is we checked whether the pet is marked adopted or not. Okay, and finally we had the adoption method wherein we call the transaction on the blockchain. So this is the overview of the user interface, the code which we have, and in the next session we are going to do the testing on this interface.